Hey folks. Hey folks. The date is April 19th, 2021, and my name is Seth Feynman. Alright, let's get started here, shall we? Okay, so today we're going to be talking about the role of the pancreas and the liver in regulating digestion. So digestion is regulated by the brain as well as the endocrine system. It's a crucial part of processing the food that we put into our bodies. And the brain is in control of our levels of hunger and satiety, specifically the hypothalamus. The endocrine system is responsible for releasing hormones and enzymes, which are an integral part of extracting as much nutrition as possible from the food that we eat. And obviously, the pancreas and the liver are part of the endocrine system. So why is the pancreas so important? There's a couple things the pancreas does that makes it such an important key player for digestion. It creates pancreatic juices, which are also known as pancreatic enzymes. These enzymes are then able to break down sugars, fats, as well as starches. In addition, the pancreas is able to assist the digestive system by creating hormones. Those pancreatic hormones are then able to help regulate blood sugar levels as well as appetite. So let's get a little bit deeper into the pancreas. These are kind of like the dirty details, the nitty-gritty. Pancreatic juices travel through the pancreas via ducts. These ducts empty into the duodenum, which is the upper part of the small intestine. The pancreas creates about 8 ounces of enzyme-filled juices every day. There are 3 different types of enzymes that are in the pancreatic juices: lipase, protease, and amylase. A little bit about each of those. So lipase, which works together with the bile, and bile is produced in the liver to help break down fats. Deficiency in lipase will lead to problems absorbing fat and necessary fat-soluble vitamins such as vitamin A, D, and K. Protease, which is responsible for breaking down proteins. Makes sense, protease, proteins. Protease also helps protect you against certain bacteria and yeast that can live in your intestines. A deficiency in this can cause allergic reactions in some individuals due to proteins being undigested. Lastly, we have amylase, which helps break down starches into sugar, which your body can then use for immediate energy. Deficiency in amylase may lead to diarrhea from undigested carbs. In addition to enzymes, the pancreas secretes bicarbonate into the duodenum, which neutralizes acid coming from the stomach. Most pancreatic enzymes are secreted as zymogens, which must be activated once they enter the intestine. The process is a several-step event that starts when enteropeptidase converts inactive trypsinogen into active trypsin, which then converts the other pancreatic zymogens to their active forms. That's a lot of words. I'm going to show you a picture of that in just a moment. I'm going to show you that now and just come back to this slide. So here we have the pancreas, the pancreatic duct. Pancreatic juices are going to flow from this into the duodenum of the small intestine. And below, we can see these zymogens. So here are the pancreatic secretions, which are inactive and active zymogens. As I said before, they are activated once they enter the intestine. The process is a several-step event, which starts when enteropeptidase converts inactive trypsinogen into trypsin, which then converts other pancreatic zymogens to their active forms. Okay? And here, as I mentioned before as well, the pancreas secretes bicarbonate into the duodenum. This is the chemical makeup of the bicarbonate and the chemical processes therein. Let me go back to that slide. Okay, so we also have pancreatic hormones. Unlike the enzymes, the hormones are released into the blood and deliver messages to other parts of the digestive system. There are 4 main pancreatic hormones we're going to be talking about today: insulin, glucagon, gastrin, amylin. You might have heard of a couple of these. So insulin is a very commonly spoken of pancreatic enzyme because of its relation to diabetes. It's made in beta cells, which make up approximately 75% of the pancreatic hormone cells. Insulin allows your body to use sugar for energy. It's the chief hormone in your body for metabolizing sugar. And deficiency, as I said before, will lead to rising sugar levels in the blood and possibly diabetes. Glucagon, which is created by alpha cells, makes up about 20% of the pancreatic hormones. Glucagon can help raise blood sugar levels if they do get too low. They do this by sending a message to your liver to release stored sugars. Gastrin, mostly made in the G cells of the stomach, but a portion of it is made in the pancreas as well. It stimulates the stomach to create gastric acid. Lastly, we have amylin. Like insulin, also made in beta cells, but in contrast, amylin helps control the appetite and emptying of the stomach. Here's that photo as I showed before. Okay, moving on. The liver. What's so important about the liver? The biggest thing the liver does is secrete bile, which is going to break down fats. So the liver is going to process nutrients that were absorbed from the small intestine. Bile from the liver, as I just mentioned, plays a major role in digesting fats as well as important vitamins. Bile is secreted from hepatocytes, also known as liver cells. Bile is made up of bile salts, bile pigments such as bilirubin, and cholesterol, which is excreted into the feces. Bile salts can be thought of as detergents to make fats soluble for digestion. Lastly, the liver detoxifies possibly harmful chemicals. It's responsible for breaking down and secreting many different drugs, including pills and alcohol that could otherwise be very toxic to our bodies. So here's a little bit more nitty-gritty about the liver. In addition to producing bile, the liver also creates albumin. Albumin is a blood protein that transports hormones, drugs, and fatty acids through the body. The liver removes waste products 24/7, all day, every day. It also helps maintain healthy level of blood sugar. An interesting and I think pretty cool feature of the liver is its ability to regulate glucose in the blood. So it's able to supply glucose when the blood sugar is too low. And amazingly enough, it can actually remove glucose from the blood when it's too much. To me, this just really goes to show the adaptations and evolution that has taken place over millions of years so that we could properly digest such a wide range of different foods. Here we have a photo of the liver as it relates to the digestive system. The blood is going to go down the aorta, the aortic arch, and into the hepatic artery, as well as into digestive tract arteries. Now you can see the capillaries of the digestive tract. This is the stomach, intestines, pancreas, and spleen. And the nutrients are going to get transported to the liver, where they're going to get detoxified, and fats will be broken down, and eventually that blood will be brought back to the heart via the inferior vena cava. So these are my references. And once again, thanks so much for tuning in. I really appreciate it. I hope you all have a great day. Feel free to send me an email or anything if you have any questions at all.